Very good afternoon, all of you. Yes. All of you, very good afternoon. Thank you, Pradeep. Okay. Right. Shashank. Kashish. Devansh. Banso. Yashraj. Akash. Siva. Sangvi. Nisha. Thanya. Divya. Arun. Rajendra. Yes. Okay, dear. Okay. Very good afternoon, everyone. Okay. So I think all of you have gone through the yesterday's basic concepts of the matrices. Some definitions have given which are very important for further classes or further topics of linear algebra, right? Okay. Okay, dear. Right. Very good. Yeah, very good afternoon. Okay. So let's come back to the classes. Let's come back to the class. Let us start. Now, today I'm going to take there are some three kind of different matrices are there. So which we have to study about them, and afterwards we are entering into the main concepts of the linear algebra. I can say that, right? Okay. Now let's move on to this. Yeah, I think yesterday I stopped at this idempotent matrix beta, right? So this is the matrix here, idempotent matrix. Saurabh, you have to wait, right? A n by n is an idempotent matrix if and only if a square is equal to a. That's what. So if any matrix is multiplied by itself and you are getting the same matrix, so then you are saying that that matrix is an idempotent matrix. So this is the definition of idempotent matrix. This is just like a idempotent property, right? Okay. Now there are some points to be taken here. There are some note to be taken here. That the first one is, if a square is equal to a, so then we can say that a power n is also equal to a here, right? Second one, if ab is equal to b and ba is equal to a, right? So then a square is equal to a and b square is equal to b. So what is the second property is that, yes, if a and b are multiplied, if a and b are multiplied here, a and b are multiplied, and you are getting the result as the second matrix, and if you are multiplying this b into a, so in that the second matrix as the result you are getting. So whenever these two things are happening, so we can say very clearly and we can prove that a square becomes a and b square becomes b here. Okay, so whenever these two happens, so then we can straight away can say that yes, a square becomes a and b square becomes b here. Okay, so that's the way. So this property is there. One more thing, and there is another property, that is the third one. It is similar to the second one. If AB is equal to A, that means the first matrix as a result and the BA is equal to B. So in this case, the first matrix as the result, so then also here A square becomes A and B square becomes B here. A square becomes A and B square becomes B here, right? So these are the three properties we can remember, and we can take it as a note or properties, so that we can make use of them into the problems here. But if anybody wants to know, sir, how the things are happening here, okay, if you want to check it out, okay, just concepts wise, just to build your concept, let us see this one. Now dear students, if A square is equal to A, then we can prove that A power n is equal to A. We can prove that, okay? But if A power n is equal to A, then A square is equal to A may be or may not be. So converse is not true here, it is. Converse is not true. So if A square becomes A, then A power n is equal to A. You wanted to see this? Let's see here. Now let A square is equal to A. As per this, I am considering that A square becomes A. Now what I do is multiply by A on both sides. Multiply by A on both sides. Then what you get here, it is that becomes A cube is equal to A square, right? A cube becomes A square. But what is already A square, beta? What is already A square? A square is equal to A. So that if I substitute it here, so then I am going to get it as this is A, right? If I am substituting A square is equal to A here, so then I am getting that A cube is equal to A here, right? Now similarly, if you multiply again on A on both sides, so then it gives you A power 4 is equal to A square. Then again A square becomes A. So therefore A power 4 is equal to A here. So hence I can say that here, so this goes on and say that A power n becomes A here. So this is what the way you understand the proof of it. But here, my dear students, if you take the A power n is equal to A, so you may not get the same that A square is equal to A here. You may not get. So converse is not true. If you want to take, you can take it here. So converse is not true here. Converse is not true for this case. Okay, right? So that's why I wrote it as if and then. If it is converse is also true, suppose, generally we write it as if and only if. I think this terminology is useful for computer science students in discrete mathematics. This terminology. If then is an implication. If and only if is a by implication. Right or not? So that's a difference. So you might be studying that logical truth. Okay. So logical truth or logical statements you will be coming across. So implications, by implications in discrete mathematics. So I think you understand them, right? Okay. Similarly, in the similar case, we can prove the second one also. Okay, let me take the second one, dear. हम second one लेते हैं. Now, let us take the second one. In the second one here, if AB is equal to B, BA is equal to A, then A square is equal to A and B square is equal to B here. Okay? Yes, it is the first slide, Anishka. Okay? Right. Second one, if you see, AB is equal to B and BA is equal to B, sorry, A. This is what? These conditions, right? Under these conditions, we can prove that A square is equal to A. How? Let's see. Suppose if I take A square as A into A here. Okay? If I take that A square as A into A here. Now, in place of this A, I will be replacing by BA. Right? This A can be replaced by BA. So then you are going to get it is of A into BA. A into BA here. Okay? Now, from this is a matrix multiplication associative. So since matrix multiplication is associative, we can write this one as AB into A here. So therefore, now what is AB is equal to? So AB is equal to B here. So I have already used this case. Now I am using this case. So I am getting here it as BA. But what is BA, beta? What is BA is A. So using these two things, we are able to prove that A square is equal to A. Similarly, we can prove that B square is equal to B also. Okay? So I hope you understand, right? So this is the properties, and this is the way you have to understand how these things are happening here. Now similarly you can get the third one also, right? Okay, so let us make use of these things into the problems also, into the problems as well. Okay, okay. Firoz, no, I will not. Okay, wait. So please take down these things here. So then we are going into problems on idempotent matrix here. It will be separate. Right? So I hope you have copied this, right? Now let's take one question on this, my dear. Let's take one question on this here. Now let A comma B are of same size such that AB is equal to B and BA is equal to A. So then AB is equal to B and BA is equal to A. So then A plus B whole power 5 is equal to what? So this is the question here. Now options, if I take it, options I'll take it as yeah, it's 2 power 3, and option B 2 power 4, and option C 2 cube of A plus B, and then D is 2 power 4 of A plus B here. So these are the options here. So let's do the question here, all of you. चलो बेटा करते हैं. Anishka, just take it fast. Otherwise, you take photos of it. Okay, now. Now let's take this question, my dear, without any delay. So we'll take the solution for this, right? Okay. So what is the hint is given in this question, my dear? What is the hint is given in this question? The hint is given that AR and B are of same size. Okay, no. And then he has given that AB is equal to B and BA is equal to A here. So since from this I can say given here AB is equal to B, okay, and BA is equal to A. So then I can say this implies A square is equal to A and B square is equal to B by using which property? Property 2. By using property 2, right? Okay. So now, yes, we have AB, we have BA, we have A square, we have B square. See, generally dear, using this AB, BA, A square, B square, we can have A plus B whole square. So what I will do is, so therefore I'll consider that first of all A plus B whole square. That can be written as A square plus B square plus AB plus BA. AB plus BA. Because all of you, you know, some people will say that here a square plus b square plus 2ab, right? But 2ab is not correct. When it is 2ab, when ab is equal to ba, then it becomes 2ab. But actually in matrix multiplication, you know that ab is not equal to ba here, correct? So therefore, it cannot be written as a 2ab. It can be written as ab plus ba. So please understand this one. So some of the students will have a wrong perception. So make it correct in this way. Now, what I will do here, चलो, अभी a square क्या होता है बेटा? अब a square क्या होता है? A square is a, और b square क्या होता है? b square क्या होता है? b, और ab क्या होता है? Right? That is b, and ba क्या होता है? So that is a here. So now it has become, that is 2 times of a plus b. It is 2 times of a plus b, you are getting it. So for a plus b whole square, it is 2 times of a plus b. So now what I do is, to get the a plus b whole power 5, every time you multiply a plus b, it will take lot of time. So instead of that, we can square it. अगर हम square करते हैं तो जल्दी से जल्दी आएगा. तो square on both sides. So then I will be getting this one is a plus b whole power 4 is equal to, so 2 square of a plus b whole square, right? But what is a plus b whole square beta? A plus b whole square is 2 power 1 into a plus b. So this I am substituting in this. So then I am getting here it as 2 cube of a plus b. 2 cube of a plus b. I think now you can generalize. A plus b whole square is 2 power 1 into a plus b. A plus b whole power 4 is 2 power 3 into a plus b. So can I generalize in here? By generalization here, a power a plus b whole power n can be understood as 2 to the power of n minus 1 n minus 1 of a plus b here. Okay, so this is what we can understand from this example here. So the answer will be of D. Answer will be of D here. Okay, so very good. Many of the students have given the right answer. Very good. Yes, good beta, good. See, whatever you learn here as a property or as a note or as a condition, as a shortcut or as a formula, that everything, if you do at least one problem, so then all these things can be remembered automatically. So in such case, you need not to by heart all these cases. Okay, so and they effectively you can remember them. Okay, if you do the problem on every property here, right? So in this question, we have used the second property and first property. Both we have used and we have come to a generalization. The answer is this, right? Okay, fine. Okay, dear. So I hope you have done it this and you have copied this, right? Good. Now, the next question I am going to take it as, yes, next question I am going to take. Yeah, instead of this next question, okay, in this case, yeah, I will go for the next definition, that is involutory matrix here. Yes, beta, involutory matrix. What is involutory matrix here? Yes, you can do it, Miss Shweta. You can do it, Shweta. Okay, somebody is asking, I think Divya Bharati. Divya Bharati, you have not understood this condition here. What I have done is I generalized it. See, I got a plus b whole square as 2 power 1. I got a plus b whole power 4 as 2 cube. So what is a plus b whole power n can be written as 2 to the power of n minus 1. So then for n is equal to 5, it is what? It will be 2 power 4. See, this is, you are forgetting this. I think you are not seen this. Okay. Otherwise, what do you do it? You do it one more time, a plus b on both sides. So what you do is here multiply a plus b on both sides. Then you will be getting, that is a plus b whole power 5 is equal to, it is a 2 cube of a plus b whole square here. So then it is of here, yes, what is 2 a plus b whole square is? A plus b whole square is nothing but 2 times of a plus b. If you do it again, so it will become 2 to the power of 4 of a plus b here. Okay, Divya Bharati? But what I did is generalization. Okay, today I asked for a plus b whole power 5. But suppose in the examination they may ask for a plus b whole power 10. Then how you can give the answer? It will take a lot of time or not? Yes, it will take a lot of time or not? So that is why I wanted to give you the simple and the way of doing it. It's not self matrix, Mr. Aniket. Okay, I will show it better. I will show it. Yes. Goyal, take it. Subhi Goyal. Okay, beta. Right. Involutory matrix is the next definition. So I think you might have written Subhi Goyal. Okay, involutory matrix here. So a n by n is involutory. Involutory if and only if it is a square is equal to I. This is the definition of the involutory matrix here. If any matrix by its, if any, it is not a formula, Rishita. Rishita, wait a minute. Rishta, yes. It is not a formula. It is not a generalized formula. It is the generalization of the question, answer. Generalization of the answer, not a formula here. Please don't consider it as a formula. For the given condition and for that problem, the answer is generalized as so and so, so that you can put any n value in under those conditions. You can put any n value over there and you can get the answer just like that. So if you want to treat it as a formula, it's up to you. But you remember that under those conditions only that formula will work out. Okay? थोड़ा clarity होना चाहिए बेटा. Right. As we are virtual, so I don't know what exactly you are feeling about that as a general formula here, right? But as per your chart, I can say, or your message, I can say that I think you are treating it as a formula, standard formula. It's not a standard formula. It is just a generalized answer, okay, for the given question under the given conditions. So this is a generalized answer, but not a formula. But if you want to consider it as a formula, you consider it as a formula under those conditions which are mentioned in the question. ठीक है? तो ये याद रखना है. Right, beta. Very good, very good. So now it is see that a n by n is an involutory matrix. So it is a square matrix, involutory, if and only if a square is equal to I. So that means here the matrix is multiplied by itself and you are getting the identity matrix. मतलब एक मैट्रिक्स अपने आप से मल्टीप्लाई करता है तो आइडेंटिटी मैट्रिक्स मिलता है. जनरली दो मैट्रिक्स मल्टीप्लाई करता है तो आइडेंटिटी मैट्रिक्स मिल गया, तो वो दो मैट्रिक्स को हम इनवर्स टू ईच अदर कहते हैं. So therefore here, so from this I can say this one as a into a is equal to I. A into a is equal to I here. Okay, so then it becomes here a is equal to A inverse. The matrix is self inverse. Increase the pace. Okay, beta. Yes, A is equal to A inverse. So the matrix itself is the inverse of it. So that is called a involutory matrix here. Okay, fine. Now the next one is nilpotent matrix. Nilpotent matrix. Please take this heading, that is nilpotent matrix. So what is that nilpotent matrix is? Nilpotent matrix is nothing but here A n by n is nilpotent of degree or index k if and only if A power k is equal to a null matrix. A power k is equal to null matrix here. So this is the condition for the nilpotent matrix here, right? So whenever any matrix is multiplied for some k times and you are going to get the null matrix, suppose if you are getting the null matrix when A is multiplied for k times, so then that matrix is called as the nilpotent matrix of degree k or index k, right? So that's what the that is nilpotent matrix we say about. Okay, so I hope everybody should remember this definition, because ये definition के ऊपर भी examination में question आया था, so that we have to do it. Okay, so that is why we have to remember all these definitions. Okay beta, so with these definitions are finished, now we are going to take the concept of the determinants. We'll take the concept of determinants here. Yes, you have to remember the names. Yes, Reyas. It's up to you. It's up to you, Shreyas. Okay, so now we move on to determinants. Please, all of you copy it very fast. Yes, beta. Okay, right. Now we are moving on to the next one, the very very important topic, that is the determinants. Yes बेटा, हम determinant से शुरू करते हैं, right? Okay. Okay, Bhuban. Okay. Right. So no issue. Let's take it. Determinants. What is a determinant, my dear? How many of you know what is the determinant of the definition of a determinant? You say definition of the determinant means, sir, it is the expansion of so and so, summation of so, product of so and so, you say that, right? But it is not that, my dear. Many of the students don't know this definition of the determinant. So determinant is nothing but here. Determinant is nothing but a factor which determines whether a factor which determines whether the linear system Ax is equal to B has unique solutions or not. Is called determinant. Is called determinant here, right? So this is what we say that it's a determinant here, right? A factor which determines whether the linear system has a unique solutions or not, right? Okay बेटा, so मैंने आपको एक simple graphical explanation बताता हूं बेटा, please समझ लेना, All of you understand this? See, this is one linear system, right? These are a set of, this is one linear system, right? ये एक linear system है, but most probably, sorry. So this is a linear system. Now we have a two equations here. Now basically, graphically, if you see, these are the two straight lines. These are the two straight lines here. Now, generally, if I am taking the lines which are like this, okay, I am taking the lines here. These are the lines, right? They are cutting at one point, right? So suppose these two lines are cutting at one point here, right? And the slope of this line and the slope of this line are same or different here. By looking at the straight lines, you can say the slope of this line and the slope of this line are different. So then we are able to see graphically only one solution, that is unique solution here. That is unique solution here. Correct or not? Graphically समझते हैं बेटा. So now so it is very clear. Now I am going to take it here, the slopes. So what is the slope of this and this here? The slope of this one is minus b1 by a1, and that is minus b2 by a2 kind of things, right or not? Okay. So now it is here I can say that a1 by b1 is not equal to a2 by b2. a2 by b2 here. Okay. So this is the unique solution condition here. Since the slopes are not equal for this unique solution, so I mean only one intersection, so a1 by b1 is not equal to a2 by b2. That is, slopes are not equal. So from this we can write here a1 cross multiply a1 b2 minus, and this one is a2 b1, and this is not equal to 0. Are you getting my point here? Are you getting my point here? This is what here. So dear students, so if they are equal, it is equal to 0. If they are not equal, it is not equal to 0. So that means it is very clear, this is the factor. This is the factor if it is not equal to 0, so that the slopes are not equal to 0, so that this linear system will have a unique solution. है ना? Right. अगर if a1 b2 minus a2 b1 is equal to 0 समझो, so that means the slopes are equal. If the slopes are equal, so definitely, so they are cutting at this different number of points like that, or the slope, they are parallel to each other kind of things here. Okay. So for this unique solution, definitely this should not be 0. अगर ये 0 equal to 0 है, slopes equal होता है. अगर वो slopes equal होता है तो ग्राफ ऐसा नहीं होगा, ऐसा होगा, नहीं तो ऐसा होगा. तो तब इसमें से यूनिक सॉल्यूशन नहीं होगा, नो सॉल्यूशन होगा, नहीं तो इनफाइनाइटली मेनी सॉल्यूशन हो सकता है. तो इसमें तो बहुत सारा सॉल्यूशंस है, इसमें तो नो सॉल्यूशन है, ये कभी कट नहीं करेगा, ऐसे सॉल्यूशन होगा. सो इट इज वेरी क्लियर दैट if it is equal to 0, so that means they do not have any they do not have unique solution. If this is not equal to 0, so this has a unique solution. So now it is very clear, my dear students. So this is the factor which determines whether this linear system has unique solution or not, is called as determinant here. So this is the a1 b2 minus a2 b1 is called determinant of this linear system here. Sir, how do you understand this determinant of a matrix? Let's see, all of you. Now, everyone knows that this can be written into matrix form or not. चलो बेटा हम थोड़ा इधर से लिखते हैं, right? इधर से लिखते हैं, मैट्रिक्स फॉर्म में लिखते हैं. इसका मैट्रिक्स फॉर्म क्या है? इसका मैट्रिक्स फॉर्म क्या है? राइट? इसका मैट्रिक्स फॉर्म क्या है कि a1 b1 a2 b2 into xy is equal to c1 c2. Is it, sir? Is it? So now you say this a1 b2 minus a2 b1. So here we are defining the determinant of a. So this is a and this is x and this is b here. Now the determinant of a, that means the determinant of this coefficient matrix is given by here this a1 b2 minus a2 b1. So this is the operation which is equal to this, and which we consider it here as the determinants of the matrix here. So determinant of A is equal to A1 B2 minus A2 B1 here. A2 B1. So ये ग्राफिकली मैं आपको समझाया था, तो ग्राफिकली हमको ये समझ में आया कि ये फैक्टर अगर नॉट इक्वल टू जीरो है तो यूनिक सॉल्यूशन, इफ दिस फैक्टर इज इक्वल टू जीरो है तो नो यूनिक सॉल्यूशन, राइट. And what is this factor you understand means with this operation like AD minus BC will give you the factor that we are understanding as the determinant of this coefficient matrix in this linear system. So this is what exactly the determinant of the given matrix here. Okay. Yes, Sandeep Paul, you are right. Right? Okay. So that's what the definition of the determinant is basically here. So I hope everyone has understood that. मैंने आपको लीनियर सिस्टम के तरफ से बताया और ग्राफिकली भी बताया, ठीक है, राइट. Yes. Determinant can be found for only square matrix. Only for square matrix. Okay? Right. So please copy this. Now I will tell you how to find out the determinant of the higher order matrices. If it is of 2 by 2, you know A1 B2 minus A2 B1. But if it is of 3 by 3, 4 by 4, 5 by 5, 6 by 6, how you find the determinant of the matrix here? That I will tell you here. Right? Great, great Akash, very good. Akshay. Okay, right, copied na, fine, yes beta. So now let's move on, method of finding the determinant here, finding the determinant here, method. Now see, if you want to find out the determinant of a n by n matrix, here, right? Now, dear students, out of n rows and n columns, please understand, there are n rows and n columns in this matrix. Out of n rows and n columns, any one row or any one column has to be fixed. किसी एक को fix करना है, चाहे वो फर्स्ट रो, सेकेंड रो, थर्ड रो, फर्स्ट कॉलम, सेकेंड कॉलम, थर्ड कॉलम, कुछ भी, whichever you feel convenient, you can fix that. But generally, for the definitions purpose, we will be fixing the first row. But it doesn't mean that you need to take only first row. You can take any row can be fixed or any column can be fixed here. So therefore, in this, to give this determinant definition here, okay, now fix I is equal to 1. तो मतलब मैंने फर्स्ट रो को फिक्स किया बेटा, फर्स्ट रो को फिक्स किया. सो दिस इज गिवन बाय, सो द डिटर्मिनेंट ऑफ दिस मैट्रिक्स इज गिवन बाय फिक्सिंग द फर्स्ट रो एज समीशन j is equal to 1 to n, where j stands for column, 1 to n and minus 1 whole to the power of 1 plus j. Because I already fixed that I is equal to 1, so it is I is equal to 1 here, 1j, right? Then into a1j into delta 1j here. So where 1 is nothing but first row. So this is the first row element, a1j means first row element. What is delta 1j? See, delta 1j is understood as the minor of this element. This delta I1j is understood as the minor of this element here. But now let us see how you find the minor of this element. Okay, I will explain you very clearly. Right, now let me write this, where delta ij is nothing but the minor of an element aij. So it is the delta ij is understood as minor of the element aij. What is the minor of an element, my dear? एक एलिमेंट का माइनर कैसे लेते हैं एक मैट्रिक्स में? लेट मी टेल यू हियर, remove the ith row and jth column of that element, of the corresponding element. The corresponding row and column of that element has to be deleted. एक रो एक कॉलम निकालने के बाद you will be getting a sub matrix here. You will be getting a sub matrix. Now the determinant of that sub matrix is nothing but called as minor of that element aij. Minor of that element called aij. So many of the people have understood, but still I'll show you just by putting this into some steps. Right, now this is what the way. For j is equal to 1 you expand it, then plus for j is equal to 2, for j is equal to 3, for j is equal to 4, like up to j is equal to n. So you have to take the sum of all these products. So is nothing but the will give you the determinant of the given n cross n matrix here. Chalo beta. So now let's take that a 3 by 3 determinant of a11, a12, a13, a21, a22. जल्दी से जल्दी करते हैं बेटा, because ये तो सबको मालूम है, right? But just a brief review, just brief review here. That's it. Just everybody knows here. Now, dear students, we are fixing I is equal to 1. Fixing I is equal to 1, just as I said here, right? First row को fix करते हैं बेटा, इसको fix करते हैं, right? Now, so then this determinant is given by, yes, go to the summation, all of you. Take first summation j is equal to 1. So release this summation for j is equal to 1. So it will be minus 1 whole to the power of 1 plus 1 into a11 into del 11 for j is equal to 1. For j is equal to 2, it is that minus 1 whole to the power of 1 plus 2 into a12 into delta 12, then plus minus 1 whole to the power of 1 plus 3 into a13 into delta 13 here, a13 into delta 13 here. So this is the way I am taken, because there are 3 rows and 3 columns. So as there are 3 columns, so you are taken up to 3. Right, now dear students, how do you take this one? Right, so now it is minus 1 whole power 1 plus 1, it is plus, so it's generally taken as plus here, that is a11 into del 11. Dear students, what is del 11? Let's see. It's a del 11 means it's a minor of an element a11. a11 का minor है. So just delete that row and column of a11. So then you will be having a submatrix here. The determinant of this submatrix is nothing but the delta 11 here. That is the determinant of, here you say a22, a23, here a32, a33. Right? Then here minus 1 whole power 3, that is minus, and then a12 into, here it is a determinant of, yes. Now beta, अब क्या है? So ये minus है, right? Now you have to take the minor of a12. Minor of a12 means delete that row and that column of that element. So then you will have this a21, a23, a31, a33. So let's take the minor of this a21, a23, a31, a33 here, right? So then I'll be moving on to plus here it is of A13 into minor. So what is the minor? Del 13 is what? What is del 13? Del 13 is what? So it is a minor of A13. So delete the first row and third column. You will have this. So determinant of this is nothing but the minor of it. So it is A21, A22, A31, A32. चलो बेटा अब आप देखना एक बार. यस, AD minus BC, AD minus BC, AD minus BC. So this is how you are going to find out the determinant of this 3 by 3 matrix here. So I hope everyone understood this, right? Okay. So this is how you are going to get it here. So I hope you have copied parallelly because it's a very well-known topic. So parallelly people have copied, I feel, and you have to copy parallelly. Okay. If anything is something you are studying for the first time, you don't know anything, so then I'll give more time to copy for you. But if some things are very basic and you know already, so I think you can copy both parallelly and listen. Write and listen parallelly. Yes, done. Very good. आपके लिए क्वेश्चन बेटा, आपके लिए क्वेश्चन, राइट? सो आर यू रेडी फॉर इट एवरीवन? चलो देखते हैं. Yes. See, it is a 2 by 2 matrix, correct? It's a 2 by 2 matrix. Now, in the determinant expansion of this 2 by 2 matrix, how many terms you are getting? How many terms you are getting in the determinant expansion of 2 by 2? You are getting 2. You are getting 2 terms. Okay? In the determinant expansion of 2 by 2 matrix, you are having 2 terms. Generally, you will get 2 terms. Generally. Right? Now my question is, how many terms you will be getting in 3 by 3 matrix? Yes. How many terms you will be getting in 3 by 3 matrix, determinant expansion of 3 by 3 matrix? Anybody? Just look at this. एक 2 by 2 इधर है, एक 2 by 2 इधर है, एक 2 by 2 इधर है. Right? कितने होगा? How many terms you will have in the determinant expansion of 3 by 3? कितने होगा बेटा? कितने टर्म्स आ सकता है इसमें? अगर 2 by 2 वाला 2 ले लेते, अगर 2 by 2 वाले के लिए 2 लिए तो 3 by 3 के लिए कितना आएगा? तीन बाई तीन के लिए 6 बोल रहे हैं. वेरी गुड बेटा, वेरी गुड. सो इट्स 2 2 2. सो टोटली 6 you will have. Totally 6 you will have. Okay. Now my question to you, all of you, if it is a 4 by 4 matrix, suppose if I have a A14 also like this, here I have A14 also. If I have A14, A24, A34 and one more row like this, a 4 by 4 matrix suppose अगर ये 4 by 4 है तो कितने टर्म्स होगा डिटरमिनेंट एक्सपेंशन में? How many terms you will have in the determinant expansion of 4 by 4? In this, the number of terms कितना होगा? How many number of terms आएगा? 6 is the correct answer for 3 by 3. Correct. Very good. Some of the students have given, yeah, 4 factorial. Okay beta. See, okay, in a 4 by 4 matrix what happens? If you fix the first row, if you take one element and multiply by its minor, so इसका minor क्या होगा? 3 by 3 होगा. So for a 3 by 3 already you have 6. So like that, this element have 3 by 3 minor, this element also have 3 by 3 minor, this element also have 3 by 3 minor, this element also have 3 by 3 minor. That means there are 4 3 by 3 minors are there. That means there are 4 3 by 3 minors are there. सो एक 3/3 मैनर के लिए 6 होगा, तो 4 3/3 मैनर्स के लिए कितने होगा? तो इट इज सिंपली 4 into 6, that is 24. That is 24 here. That is 24. ओके कुछ लोग बता रहे हैं 4 into 2 8 करके, ऐसा नहीं होगा बेटा। जब 3/3 के लिए माइनर 2/2 मिलता है तो 2 टर्म आएगा, मगर 4/4 के लिए माइनर 3/3 होगा, तो 3/3 का 6 टर्म मिलेगा, तो 6 into 4 तो 24 होगा। वेरी गुड, 24 मेनी पीपल हैव गिवन। सो फॉर 5/5 व्हाट हैपेंस? फॉर 5/5 you will have 5 into 24, because there are 5 elements, every element will have a minor of 4/4 for 5/5. 5/5 के लिए 4/4 minor आएगा, तो 4/4 24 terms are there. So like that in a 5/5 matrix we'll have 5 elements in every row. So 5 elements into 24 terms is going to be 120 terms you are going to get in 5. So this is understood as 4 factorial here, and this is understood as 5 factorial here, and this is understood as 3 factorial here, and this is understood as here, this one is understood as only 2 factorial. Okay, अगर आप सही तरह देखते हैं ना, तो for 2/2 the number of terms you are going to get is 2 factorial. For 3/3 you are getting it is 6, that is 3 factorial. For 4/4 the number of terms you are getting to 24, that is 4 factorial. For 5/5 you are going to get is 120, which is 5 factorial. So therefore my generalized answer, my generalized this thing is that, my generalized statement from this is that the number of terms, all of you please write it in your notes, the number of terms in the determinant expansion of a n by n is equal to n factorial terms, is n factorial terms. Yes Viswaroop, correct. Yes beta, very good, wonderful. चलो आगे चलते हैं बेटा. So this is the definition and some minimum points of determinant and all this definition procedure and all those things here. चलो बेटा, actually problem ये है ना, for 3/3 बोले तो जल्दी से जल्दी निकाल सकते हैं, right? If for 3/3 it is very easy to find the solution for it, but for 4/4 it will take certain time. For 5/5 it will take more time, because the number of terms are getting increased. 120 terms means it will take a lot of time of expansion here. So then what are the techniques and what are the shortcuts and what are the simple way of finding the determinants of such higher order determinants? What are the procedures that we will see little later. Okay, right. Right. So now I'll go into the properties of determinants. Beta. Properties of determinants. Properties of determinants. First one. Write down this. Mod A is equal to mod A transpose. Second one is mod of AB is equal to mod A into mod B. Right. Third one is mod of A power n is equal to, fourth one it is of mod of A inverse, right, is equal to. Fifth one is that yes, K B C D, okay, is nothing but K times of A B C D and then K A K C B D here. Then it is. Now the sixth one is of determinant of K A n by n here. Now what is this is equal to here, right? Then we'll go for seventh one, that is the determinant of adjoint of A n by n is nothing but mod A to the power of n minus 1 here. and eighth one is very very important here, that is adjoint of a n by n is nothing but mod a to the power of n minus 2 into a, and ninth one is mod of adjoint of a n by n is nothing but mod a to the power of n minus 1 whole square. Okay. Yes, Galio Singh. Sir, what about when m not equal to n? So when m not equal to n, we don't find the determinant, my dear. Okay, we don't find the determinant here. That you will understand little later. Okay, so these are the properties one has to know, right? Please take it on. Done. Yes. Now coming to this here, mod AB is equal to mod A into mod B here, right? Why it is not clearly visible, my dear? एक काम करते हैं, मैं थोड़ा बढ़ा देता हूँ. चलो अब लिखो बेटा 8th and 9th. हर्षिता. Adjoint of adjoint. Okay. Right. चल ये है, right. Okay, fine. So mod A is equal to mod A transpose. That means even though you interchange the rows and columns, the determinant does not change. ये ट्रांसपोज में एक तो चीज कॉमन है बेटा, ना डिटर्मिनेंट चेंज होता है, ना रैंक चेंज होता, ना आइगन वैल्यू चेंज होता है, ना आइगन वेक्टर्स चेंज होता है. ठीक है, याद रखना ये A and A transpose have the same eigen values, same eigen vectors, and same determinant and same rank. Okay, right. Now second one is that the determinant of product of two matrices is equal to product of their determinants. Product of their determinants. So suppose if according to this point, see देखो बेटा, ये point को use करके what about mod A square? How do you find out the mod of A square here? So mod of a square can be understood as mod of a into a here. Correct or not? Correct. So as it is written as mod a into a, so can I use this property here into this property here, that mod ab can be written as mod a into mod b. So it is written as here mod a into mod a, that is mod a square. Correct. So mod a whole square is equal to mod a square, here it is. So mod a power n is nothing but can be written as mod a whole to the power of n here. So sometimes if you want to find out the determinant of a power 50, so you need not to find out the a power 50 and then find the determinant. No need. Just find the determinant of a and multiply it for 50 times. Then that is the determinant of a power 50 here. So this is how the properties will be helpful for us to give some answer very quickly and very fastly here. Now, and this one is nothing but mod a to the power of minus 1, which is understood as 1 by mod a. It's a reciprocal of its determinant here. Reciprocal of its determinant. This is the fourth property. Now, fifth property you can see that here. In a determinant, you can take a scalar k common from a row, from each row you can take the scalar multiple k common here. So in this row, as k is a scalar is existing in both, so you can take k common from this row. So then if you want to take this scalar k common from this row in the determinant, then it is written as, yes, as k is taken common here, it is written as k times of the determinant of this a, b, c, d here. Right? So like that, row wise you can take the scalar common. Suppose if similarly here this side you can see that. As how you take that k common from a row, similarly you can take a scalar common from column also like this. See, in this column k is a scalar multiple here. So I can take this scalar k common from this column and then it is written as the k times of the determinant of a, b, c, d. So like this, जैसे रो से कॉमन लेते हैं वैसे कॉलम से भी कॉमन ले सकते हैं स्केलार को इन ए डिटर्मिनेंट. ओके, डिटर्मिनेंट के अंदर से रो वाइज कॉमन ले सकते हैं और कॉलम वाइज भी कॉमन ले सकते हैं. ठीक है. एंड नाउ सपोज इफ आई हैव दिस वे, राइट, सपोज इफ आई हैव द के इज फॉर दिस सेकेंड रो ऑल्सो, so then what will be the can be written as here. So some people will misunderstand that. Okay, you are taking the k common from all the elements. So no, it is in a matrix, but here it is a determinant. In a determinant we have to go row wise or column wise. So from this row I can take one k common here, right, and another row, right. From this row you are taking one k common, and from this row also you are taking another k common. So therefore totally it becomes k square of ABCD. K square of ABCD. I hope you understand. So like this, from each row you can take a scalar common in the determinant. So I think everybody knows this property, but I am telling you before that. Why? Because now you understand why I told that. चलो बेटा, इसका आंसर क्या है? सिक्स्थ का आंसर क्या होगा? डिटर्मिनेंट ऑफ k इंटू ए इन बाई एन हियर. सो व्हाट इज हैपेंड हियर? इसमें क्या हो रहा है? पहले k is a scalar which is multiplied to the complete matrix. So when you are multiplying k to the complete matrix means it is multiplied to all the rows or not. So after multiplying this k to all the rows, then you are finding the determinant. तो पूरा k मल्टीप्लाई करने के बाद फिर आप उसका डिटर्मिनेंट लेते हैं. सो देन व्हाट कैन बी रिटन हियर? सो नाउ इन ए डिटर्मिनेंट यू कैन टेक द स्केलर कॉमन फ्रॉम ईच रो. सो जैसे इसमें एक रो में और दो रो, सो दो रो में से दो के, बट हियर कितने रो है? n rows are there. So therefore how many k's will get common here? n k's will get common. So therefore it is written as k power n into determinant of a here. Determinant of a here. Okay, so if it is of one row, it is k power 1, right? If it is of 2 rows, it is k square. If it is for multiplied for all the n rows, then this can be written as k power n times of determinant of a. Dear students, this बहुत सारा स्टूडेंट्स इसमें गलत इस्तेमाल करते हैं. थोड़ा आप ध्यान रखना पड़ेगा, अच्छी तरह इंप्लीमेंट करना पड़ेगा. Be careful with this. Okay, right. Anybody can say what is the answer for this? What is the answer for this? Anybody? देखता हूं. How many of you will give the right answer for this? Four. Yes. So 2 is a scalar k is multiplied to 2 rows of identity matrix. So it becomes k square of mod I. So what is k here? 2. So it is 2 square of into 1. So that is answer is 4 here. Yes, 4 is the right answer. See, still some people have given wrong answer. Okay. Not 4 mod A, it is 4 only. हर्षित गार्ग चेक करना बेटा, ये 2 नहीं है, ये 4 है. आकांश, अमूल्या, मुनिबली, शिवांशु, अभिजीत, राजनंदनी, अभिनवा, दत्ता, प्रदुम वर्मा, आर्यन, ये सब लोग आंसर गलत दिया बेटा. गौतम श्रीकांत, योर आंसर्स वर रॉन्ग. विश्वजर उपलब्ध. सी, आई हैव प्रूव यू, आई हैव प्रूवन. See here, I've already proved you that, see, many of the students will go mistake at this point. सिद्धांत भी गलत है, अर्पित भी गलत है, गौरव कुमार is a wrong answer. ओके. सी, मुझे पता है बेटा बहुत सारा स्टूडेंट्स उसमें गलत करते हैं. इसमें गलत, आई मीन यू विल नॉट यूज दिस प्रॉपर्टी इन ए करेक्ट वे, क्योंकि आप जल्दी में रहते हैं. यू विल बी इन हरी, यू विल नॉट एग्जैक्टली इंप्लीमेंट व्हाट इज हैपेंड ओवर देयर. इसीलिए मैंने उतना टाइम लेकर के मैं आपको एक्सप्लेन किया है. So यहाँ पर अगर एक k is multiplied to only one row, it is written as k power 1. If it is multiplied to second row also, it is k square. So if it is multiplied to n rows, it will be k power n. I told you ना. So that way, why I explained that much, because of this mistake. तो बहुत लोग ये गलती करते हैं बेटा. Okay, बहुत सारा लोग ये गलती करते हैं. ये I2 means it's a 2 by 2 matrix, identity matrix of 2 by 2. गलत करते हैं बेटा, बहुत लोग गलत करते हैं. ठीक है सिद्धांत. ओके, राइट. ओके, एनीवे, सो दिस इज द थिंग हियर. एंड सिमिलरली, mod of adjoint of a n by n is given by mod a to the power of n minus 1. You can prove it from the definition of a inverse. From the definition of a inverse, right? And one thing, this is very important बेटा, ये important है कि ये adjoint of an adjoint of a n by n is simply given by the determinant of the matrix. That is mod a to the power of n minus 2 into a. If you know the determinant of a, so then you can write what is the value of adjoint of an adjoint of a n by n. Generally adjoint find out करना बहुत टाइम लेता है बेटा. उसमें कोफैक्टर बनाना है, माइनर बनाना है, मैट्रिक्स बनाना है, इसका ट्रांसपोज लेना है, तो adjoint बनाना है. So it will take. So now we are finding the adjoint of an adjoint of the given matrix, means it takes lot of time in generally, but that entire process is bypassed and simply we can give the answer with this formula. Okay, so since it is an identity matrix, how it will change, sir? It will change. Why it is changes? Understand this property. Understand this property, Divyavarti. It will not change. It's a 2 times of I2, na? You are not applying the property, Divyavarti. Property 6 को apply करना है. This property 6 you are supposed to apply here. Okay, right. So this is the thing. Now after knowing this formula, if you put mod on both sides and apply the 6th property, applying the 6th property, you are going to prove the 9th one also, that is mod a to the power of n minus 1 whole square here. Now let's have Gaurav Kumar is asking that, sir, what is adjoint, sir? Please take some time for this. Yes, जब adjoint का सेशन आता है तब लेंगे बेटा, पहले तो हम डिटर्मिनेंट्स कर रहे हैं, ठीक है. डिटर्मिनेंट कंप्लीट होने के बाद जब एडजॉइंट का जरूरत पड़ता है तब जाएंगे, ठीक है. ओके, आई थिंक ऑल दिस एवरीबडी नोस ना. एडजॉइंट अब तो सुने हो ना ऑलरेडी. यस, एडजॉइंट क्या है, वो क्या है, ये क्या है, सब तो सुने ही हुए हैं. तो आई थिंक यू कैन रीड. चलो आगे चलते हैं. अब तो प्रॉपर्टीज पढ़ चुके हैं आप लोग, राइट. नाउ लेट्स टेक वन क्वेश्चन एंड प्लीज गिव द आंसर्स फॉर दिस क्वेश्चन. Mod of a 3 by 3 is equal to 4. Okay, so then find the first one. Mod of a transpose of whole inverse is equal to, second one, mod of 2a whole inverse is equal to, okay, and third one is mod of a power 3 is equal to, right, and fourth one is mod of adjoint of a, right, and fifth one mod of adjoint of a is what. Okay, so these many questions I want to find out this thing. Yes, मैंने सब कुछ निकालना चाहता हूँ. Yes, I want to write all these questions. Yes, beta. Find all these things when just the order of the matrix is given. So this is n here, and this is the determinant of the matrix here, right? Okay, then what is the determinant of inverse of its transpose? Okay, so basically, see, it may be anything here, it may be anything. It is the determinant of some inverse of a matrix or not, right? So determinant of a inverse of matrix is given by what? Determinant of a inverse of a matrix is given by, determinant of inverse is given by reciprocal of its determinant. Reciprocal of its determinant. So therefore here reciprocal of A transpose. Reciprocal of determinant of A transpose here by using the property 4. Right. Then what is by property 1? Property 1 says that determinant of A transpose is equal to determinant of A. So that is the answer 1 by 4. Yes. So I hope everyone understood here. Right. And the second question here, again it is the determinant of some inverse or not. Something, it might be any matrix, it's a determinant of inverse. So determinant of inverse is given by reciprocal of its determinant. So reciprocal of its determinant here. Determinant. So what is the 3? A is of order 3 cross 3 here. Right. So then it is of this. So reciprocal of its determinant. Now how do you find out the determinant of this 2A? So determinant of 2A means, yes, all of you see this. Determinant of 2A. Yes, tell me what is determinant of 2A in this. What is determinant of 2A in this? where a is of order 3 by 3, right? According to this, it is k power n into mod a. What is k here? 2. So it is 2 to the power of n. What is n is here? 3. So that is 3 into mod a. I hope you understand here. This property 6. बहुत गलत समझते बेटा, बहुत ये सिक्स्थ प्रॉपर्टी को आप लोग be careful with that. Now it is of 1 by, yes, I am taking this 2 common from all the 3 rows so that it becomes 2 to the power of 3 of remaining mod a. So that is of 1 by 8 into 4, that is 1 by 32. Okay, fine. Now what is mod a cube? So mod a cube is given by mod a whole cube here. So therefore it is of 4 cube we can write. 4 cube we can write. Okay, the next one, it is of here mod of adjoint of a. Yes dear, what is mod of adjoint a formula here? See, mod of adjoint a formula is mod a to the power of n minus 1 here. So here what is n is equal to here? Here the n is equal to 3. So mod a to the power of 3 minus 1. So mod a is equal to how much? Mod a is equal to 4. So 4 square is equal to 16. 4 square is equal to 16 here. Now there is another thing, that is mod of adjoint of a3 by 3. So this is what? So the formula for this one is mod a to the power of n minus 1 whole square. So here mod a to the power of n means 3. So 3 minus 1 whole square here, that is of 4 to the power of 4. 4 to the power of 4 here. So that is the answer for these questions. I hope everyone understood this, right? Now अगर मैं आपको और एक क्वेश्चन पूछता हूं इसमें, सिक्स्थ वन, व्हाट इज एडजॉइंट ऑफ a3 by 3? What is the answer for this question also in this question? Yes, 16 into 16, correct. Adjoint of a3 by 3 is nothing but mod a to the power of n minus 2 into a. So mod a to the power of n means 3 minus 2 into a. So mod a is how much? Mod a is nothing but 4. So it is of 4a. It is of 4a here. Hope you understood this, right? Now let's move on to the some other properties of determinant here. Very good. Yes beta, very good. So I hope now everybody understood that. So whatever the formula or the properties we write, immediately we are doing the problems on it. So now there is no problem of remembering this formula और दिस प्रॉपर्टीज, ये बहुत आसान से याद होगा क्योंकि हम उसके ऊपर से प्रॉब्लम्स तुरंत किया है. So we have done the problems immediately on these properties so that we need not to remember this or we need not to by heart these formulae at all here. So this is the process of memorizing the formulae and properties and notes, anything, any points, shortcuts or anything in the mathematics subject. Okay, please remember this. If you don't practice, what happens is you have to by heart everything, right? Very easy. Yes, it's very easy, right? Very good. So I hope that everyone is finished. Everyone has finished it, right? Now I'll be moving on to the next property here. That property number 8, 9 हो गया, 10. Write down the property 10, all of you. I'll dictate. Please do not ask me to repeat. So just start with the property number 10, all of you. Don't ask me to repeat. Huh? I'm start dictating the property 10. Please take it. The determinant of lower triangular matrix comma upper triangular matrix and diagonal matrix lower triangular, upper triangular and diagonal matrix is equal to the product of its principal diagonal elements. Principal diagonal elements. Principal diagonal elements. Example 1 0 0 2 2 0 3 3 3. So what is the determinant of this matrix? So the determinant here I can show you like this. Here, this is the principal diagonal and the elements above the principal diagonal are zeros. So then it is called lower triangular matrix here. It's a lower triangular matrix here. So then the determinant of this lower triangular matrix is given by the determinant of the lower triangular matrix is equal to product of its principal diagonal elements, that is 1 into 2 into 3, that is 6. Okay, that is 6 here. Now the next one here, 11th one. Take the 11th one here. The determinant of skew symmetric of odd order is equal to 0. Is equal to 0. The determinant of skew symmetric of matrix of odd order is 0. And of even order is a perfect square. Is a perfect square. Even order is a perfect square. Perfect square मतलब क्या होता है बेटा? 1 4 9 16 25 36 40 9 64, right? So these are the perfect squares here. So such kind of numbers will be the value of the determinant of skew symmetric matrix of even order. But odd order is straight away 0, right? Now let's take that one question here. 0 0 0 2 3 minus 1 minus 2 minus 3 1. So what is this determinant value? What is this determinant value? What is the determinant of value here? Yes, this determinant is 0 because it is the skew symmetric of odd order. It is the skew symmetric of odd order. ये ही है odd order. ठीक है, odd order है ये, right? Skew symmetric of odd order will be, the determinant is 0 here. Right. So next one is that the determinant of orthogonal slash unitary matrix. The determinant of orthogonal slash unitary matrix. Unitary matrix is equal to plus or minus 1. Is equal to plus or minus 1. Somebody said -4, it is wrong answer. Sandeep Maurya. It is 0. Sandeep Maurya, your answer is wrong, beta. Yes, it is 0. Chalo. Next, the determinant of orthogonal slash unitary matrix is equal to plus or minus 1 here, right? And the 13th one, the determinant of involutory matrix is the determinant of involutory matrix is the determinant of involutory matrix is, see जल्दी से जल्दी करते हैं बेटा, इन्वोल्यूटरी मैट्रिक्स क्या होता है बेटा, ए स्क्वायर इज इक्वल टू आई, है ना, ए स्क्वायर इज इक्वल टू आई, दिस इज द इन्वोल्यूटरी मैट्रिक्स हियर. नाउ टेक mod on both sides, then it is mod a square is equal to mod I, right? Then this can be written as mod a square can be written as mod a whole square. Mod a square can be written as mod a whole square is equal to mod I. What is determinant of identity matrix is 1. So therefore, what is the determinant of A? What is the determinant of A? So the determinant of A is equal to 1. Determinant of A is equal to plus or minus 1. Plus or minus 1. So this answer is going to be plus or minus 1. Plus or minus 1. Now 14th one, the determinant of idempotent matrix. Idempotent matrix is dash. So what is idempotent matrix, dear? Idempotent matrix is nothing but A square is equal to A. So when matrices are equal, then their determinants are also equal or not. So therefore determinants are also equal here. But mod A square can be written as mod A whole square, and that is equal to mod A here. Now this can be written as mod A whole square minus mod A is equal to 0. If you are taking this side, it can be written as this side is 0. Now from this you are taking here mod A common. If you take mod A common, then it will be mod A minus 1 is equal to 0. Right? Then here after taking mod A common, I am getting this way. Then if A into B is equal to 0 means what you can write here? Either A is equal to 0 or B is equal to 0. Is it so or not? According to this. So therefore here mod A is equal to 0 or mod A minus 1 is equal to 0. So this implies mod A is equal to 0 or mod A is equal to 1. So this is the answer for this. So either 0 or 1. Either 0 or 1. So determinant of idempotent matrix is either 0 or 1. Right. So let's move on, beta. Let's move on. I think we are taking a lot of time in this. Right. So these are the properties which one has to remember this. The next one I am going to take, that is 15th one. Okay, let me, before going to 15th, so let me take this linear dependency definition. Linear dependency definition. Linear dependency. All of you, this is a beautiful concept, but one has to have the patience to understand this concept, because you may not have studied this linear dependency concept this detailedly in your engineering classes. So why I'm focusing on this here, because I wanted to take the help of linear dependency concept, and I want to get the answers very quickly. Okay, so using this linear dependency concept we will get the answers as quickly as. Okay, तो मैंने इसीलिए क्या करता हूं, सो मैंने आपको लीनियर डिपेंडेंसी का कॉन्सेप्ट अच्छी तरह पढ़ाता हूं. अगर किसी को समझ में नहीं आता है और आपको बहुत डाउट है, ऐसा कुछ है, तो यू कैन आस्क द डाउट्स एंड यू कैन गेट क्लैरिफाइड. ओके, बट जो जैसे मैंने एक्सप्लेन किया वैसे आप समझने की कोशिश करना है. बट अपना जो प्री नॉलेज, जो प्री एग्जिस्टिंग नॉलेज होता है ना, तो जस्ट डोंट गो विद दैट. Don't go with that. Just because you know this topic, no one will teach in this. No one will teach here. But I am going to give you this lecture of linear dependency, and I hope that I can make this concept very easy for you. If you understand this, so the rest of the concepts like rank of a matrix and eigenvalues, जो सब कुछ में मैंने ये एक शॉर्टकट जैसे यूज करता हूँ, राइट? तो लीनियर डिपेंडेंसी को मैंने एक शॉर्टकट जैसा यूज करता हूँ. So I am expecting from all of you that you understand this betterly and you use it as a shortcut. Okay, right. Right. What is linear dependency? Let me write here. A set of vectors x1, x2, x3 and so on xn are linearly dependent if the linear combination of a1 x1 plus a2 x2 plus and so on an xn is equal to 0 for not all ai is equal to 0. Not all ai is equal to 0 belongs to real numbers here, right? Belongs to R here. Yes beta, ये definition है beta, right? अभय कुमार, इन्वोल्यूटरी मैट्रिक्स अलग है बेटा, यूनिटरी मैट्रिक्स अलग है. यूनिटरी मैट्रिक्स का मतलब है कि ये यूनिटरी मैट्रिक्स मतलब a इंटू ए पावर थीटा इज इक्वल टू a power theta into a is equal to I. So then a is unitary. Abhinav, Abhay Kumar. Okay. this is unitary beta. A into a power theta is equal to a power theta into a is equal to I. So then A is unitary matrix here. A is unitary matrix here. चलो हम शुरू करते हैं बेटा. लीनियर डिपेंडेंसी क्या होता है यहां पर? थिंक यू माइट हैव नोटेड दिस, राइट? ओके. Any set of vectors are said to be linearly dependent if the linear combination. So the linear combination of these set of vectors, okay, the linear combination of vectors, okay, that is a1 x1 plus a2 x2 plus and so on an xn. No need of writing this. No need of writing this. That's it. The linear combination a1 x1 plus a2 x2 plus and so on an xn. So what is this expression? I will tell you. Some scalar into that vector plus scalar into the vector plus scalar into the vector plus scalar into the vector. So this is called the linear combination of these set of vectors. Okay. अगर ये लीनियर कॉम्बिनेशन ऑफ दिस सेट ऑफ वेक्टर्स इज गेटिंग जीरो फॉर सम नॉन जीरो कोएफिशिएंट्स हियर, फॉर नॉन जीरो कोएफिशिएंट्स, सी नॉट ऑल ai is equal to 0, so that means it is very clear for non zero coefficients of a1 a2 a3 and so on an, if this linear combination is equal to 0 then they are said to be linearly dependent. ये कहना है, राइट? अगर आपको एग्जाम्पल चाहिए, सो आई विल शो यू वन एग्जाम्पल हियर. नाउ आई एम टेकिंग सम सेट ऑफ वेक्टर्स हियर लाइक 1 1 1. okay, now let me write like this, otherwise 1 2 3 here, right? 2 3 4 here, and then 3 4 5 here. Wait 3 5 1 2 3 2 3 4. Here I write, here it is 3 5 7, right? These set of vectors I am taking, my dear. These are the set of vectors here. Now these set of vectors are linearly dependent or linearly independent. My question is that are okay. अभी ये linearly dependent अब मैं आपको पढ़ाया नहीं ना, तो आप देख लीजिए बेटा. मैंने एक एग्जांपल बताता हूं लीनियर डिपेंडेंसी के बारे में. चलो, ये सेट ऑफ वेक्टर है, ये ax1, ये x2 है और ये x3 है. सो नाउ if for any non-zero coefficient a1 a2 a3, if a1 x1 plus a2 x2 plus a3 x3 should give you 0, so then we can say that these are linearly dependent. तो एक काम करते हैं बेटा. Now we'll take the linear combination. What is the linear combination we take? That is a1 into 1 2 3 plus a2 into 2 3 4 plus a3 into 3 5 7. Okay, 3 5 7. So I am taking this linear combination. I am taking this linear combination here, right? Now I am taking, and this is equal to 0 I am getting, if I am taking. Now my question is that, okay, if you don't take this 0, so this is what the linear combination I have written. Now what, according to this definition, this has to be 0 for some non-zero coefficients of a1 a2 a3 here. So for non-zero coefficients of a1 a2 a3, so what are the things you can take it here? See, आप थोड़ा ध्यान से देखो, 1 plus 2 is 3 or not, right? Okay, so यहाँ पर 2 plus 3 5 and this is 5, and then it is 3 plus 4 7 and this is 7. So now what I do is choosing, all of you please understand बेटा, ये आपको मैं ऐसा करो बोल के नहीं बोलता हूं, बट मैंने आपको समझाने का कोशिश कर रहा हूं ये लीनियर कॉम्बिनेशन जीरो नॉन जीरो कोएफिशिएंट्स के लिए कैसे होगा. For non-zero coefficient, this linear combination will get 0, will give you 0. How it is? That for that I am explaining here. So choosing that a1 is equal to 1, a2 is equal to 1 and a3 is equal to minus 1. Suppose अगर मैं 1 1 minus 1 ये सब not equal to 0 है, नॉन जीरो कोएफिशिएंट्स है. सो ये नॉन जीरो कोएफिशिएंट अगर इसमें ले लेते हैं तो लीनियर कॉम्बिनेशन क्या देगा? लीनियर कॉम्बिनेशन होगा कि 1 2 3 ओके, देन प्लस अगेन 2 3 4 प्लस, सॉरी नॉट प्लस, इट इज माइनस, क्योंकि इट इज माइनस 1 इंटू, सो माइनस 3 5 7. तो क्या देगा एक बार देखते हैं. सो सी I component, I component, I component, J, 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 K, K, K will be getting added here. Now 1 plus 2, 3, 3 minus 3, 0. Now 2 plus 3, 5, 5 minus 5, 0. And then 3 plus 4, 4, 7, 7 minus 7 is 0. See, you got the 0 vector or not? All of you, you got the 0 vector. So, for non-zero coefficients, you are getting this linear combination as 0. So, therefore, I can say that. So, therefore, here x1 comma x2 comma x3 are linearly dependent. Linearly dependent here. Linearly dependent here. So for non-zero coefficients, we are getting this linear combination as 0. So that means they are linearly dependent as per the definition here. I hope everyone understood. So if not understood, let us wait, my dear. किसी को भी अगर समझ में नहीं आया तो you just have patience. We deal this in a different way. Okay? जल्दी लेना बेटा, जल्दी लेना. Harshavardhan Reddy, not all AI is equal to 0 means, it means that, so some for the non-zero coefficients you can say that. Not all means, not all means what? Not all AI is equal to 0. Yes, okay beta, done, right, fine. Okay, I hope you understood this here, right? But मैंने ऐसा लिख सकते हैं क्या? मैं इसको सिंपल तरीके में लिखना चाहता हूं. I just want to write the linear dependency in a simple way, right? What is the practical way of understanding is that here can I get x1 plus x2 is equal to x3 or not? Right? x1 plus x2 is equal to x3 here, right? So x1 plus x2 is equal to x3 means what? So what is happening here? The linear combination of x1 and x2 is giving you the another vector x3. So then, so these three vectors are linearly dependent, you can say that. So once again I repeat here, if any vector is given by or written as the linear combination of other set of vectors, then those set of vectors are linearly dependent, we say that. If anybody wants to write, you can write. Okay. Hemant Kumar, I was choosing this A1, A2, A3 to make it the whole part as 0. Hemant Kumar, to make it 0, I was choosing that. By trial and error, you can do it. Okay. In problems you don't do that, my dear. In problems you don't do that. I just want to make you to clear that what is that concept of linear dependency. Okay? Okay, fine. So please write down that. If one vector is written as the linear combination of other set of vectors, if one vector can be written as the linear combination of other set of vectors, the linear combination of other set of vectors, then those set of vectors are linearly dependent. Okay, now you can see that here there are three vectors in it beta. इसमें तीन वेक्टर है, ठीक है. ये तीनों वेक्टर linearly dependent है कि नहीं? Whether these three vectors are linearly dependent or not, that how we understand is that clearly by observation it is very clear that 1 plus 2 is giving you 3, 2 plus 3 is giving you 5, 3 plus 4 is giving you 7. So that means it is very, very clearly understood that one vector x3 is given by the linear combination of x1 and x2. The linear combination of x1 and x2 here. So therefore this x1, x2, x3 all are said to be linearly dependent. Okay, linearly dependent here. Okay, all of you. Now suppose if I take, what is the other way of doing it? Sir, how do you understand the other way of saying that linear dependency in this? Right. So one is this way, second one is this way, right? By observation. I can say by observation. By observation, I can do like this, right? By observation, right? Next, third method beta. Third method क्या होता है? Let me tell you, all of you. How many vectors are there? 3 vectors are there, and each one is of 3 dimension, 3 dimension, 3 dimension. So there are 3 vectors of 3 dimension is there. There are 3 vectors of 3 dimensions are there. So then here you have to find out the determinant of those vectors. So what's the determinant of this one is 1, 2, 3, okay, and 2, 3, 4, and then 3, 5, 7. 3, 5, 7 here. Now let's have this determinant here. Let's find the determinant of this. So this determinant is, that is plus minus plus, so that is 1 into, it is 21 minus 20, and then minus 2 into 14 minus 12, and then plus 3 into, here it is 10 minus 9 is 1. So it is, yes, 4 minus 4 is equal to 0. So since the determinant of these 3 vectors of 3 dimension is 0, so therefore this x1, x2, x3 are linearly dependent. Linearly dependent here. So this many ways you can show the linear dependency between the set of vectors. So one is of choosing a1, a2, a3 so that you get the linear combination as 0. Okay, this is one way of saying that there is a linear dependency. Second one is that by observation, that if you can write one vector as a linear combination of other vector, right? And third method is that when you have a 3 vectors of 3 dimension, so you will have a square matrix. So then the determinant of that square matrix is equal to 0. Then we say that the vectors in that determinant are linearly dependent. So these are the 3 ways you can give the answer for this question. Okay. Sweta Maurya, yes, that is also linear dependency, because you can write x3 this side as minus x3. is equal to x4. See, Harshit Sharma, it may be, see, one of them may be 0 and none of them may be 0. It may be anything here. Okay. Sandeep, wait for that rank of the matrix concept. Yes, number of independent vectors, correct. Graphical explanation, graphical representation of linear dependency. पहले ये समझ लो बेटा, ठीक है. Okay. See here. Somebody is asking about a graphical representation. What is the graphical representation of this determinant? Anybody? Determinant 0. Factor 0. What is the graphical representation for determinant factor is getting 0? Not unique solutions. Not unique solutions में lines कैसे होगा? कैसे lines होगा? Equal slope. जो लाइंस स्ट्रेट लाइंस होता है, अगर उसका स्लोप्स इक्वल है, सबकी सब जो स्लोप्स इक्वल स्लोप होता है, सो दैट मीन्स देन वी कैन से दैट दे आर लीनियरली डिपेंडेंट हियर. ओके, अच्छा, एंड आई विल टेक वन मोर एग्जांपल हियर. आई विल टेक वन मोर एग्जांपल बेटा, ये वन मोर एग्जांपल है, ये देखना. अगर हमारे पास दो ही टाइप है, so let us take another example here. X is equal to, we have 1 2 1 and 2 4 2. That's it. We have only two vectors, my dear. Okay. Yes. Right. 1 2 1 2 4 2 here. 1 2 1 2 4 2 here. We have only two vectors in this set of vectors. Now, my question to this is a linearly dependent or linearly independent? Linearly dependent or linearly independent here. Right, very good. So, to check the linear dependency, suppose if we have three vectors of 3 dimension, then we take a determinant. But this cannot form a determinant, right? 1 2 1 2 4 2. It cannot be formed, right? It cannot form the determinant, right or not? So therefore, we don't take the determinant like this. How do we take? Let me tell you. First thing is that when we have only two vectors like x1 and x2 here, how to understand the linear dependency? How to understand the linear dependency? How to understand the linear dependency when we have only two vectors? So this is for three vectors of 3 dimension. So this is for two vectors of 3 dimension or 4 dimension or 5 dimension or 5. But when we have only two vector. अगर जब आपके पास दो ही वेक्टर होता है, वो दो वेक्टर के बीच में आप लीनियर डिपेंडेंसी कैसे देखते हैं? देखो बेटा, ये सिंपल है. लीनियर कॉम्बिनेशन अगर लिखते हैं, ठीक है. अच्छा ठीक है, बाय ऑब्जर्वेशन मैंने आपको ऐसा सिंपली कह सकता हूं, बाय ऑब्जर्वेशन अगर x2 लेते हैं, that is 2 4 2 है ना. This can I take 2 common from this? If I take 2 common from this is 1 and this is 2 and this becomes 1 here. Now after taking 2 common from this, it is written as 2 times of 1 to 1. What is 1 to 1 is x1. So that means here this is x2 is equal to 2 times of x1. x2 is equal to 2 times of x1. So आप इस तरफ देख लीजिए, मैंने इसको ऐसे लिख सकता हूं ना, x2 minus 2x1 is equal to 0. अब देखो बेटा, the linear combination of x1 and x2 is having the non-zero coefficients or not? So therefore these two are linearly dependent. सही है कि नहीं? बस तो ये बात है बेटा. So that means these two are the linearly dependent here. Linearly dependent. I hope you understand. So मैंने आपको प्रैक्टिकली कैसे बताऊं, आपको जैसे रोज को देखते हैं, कॉलम्स को देखते हैं, वेक्टर्स को देखते हैं, जैसे दो वेक्टर के बीच में डिपेंडेंसी है कि नहीं, whether the dependency is there between two vectors and two vectors or not, how to understand? Very simply, easily is that way. Here, if one vector is written as a scalar multiple of other vector, if one vector is a scalar multiple of other vector, so then we say that those two vectors are linearly dependent. But when we have three vectors or four vectors or five vectors, so how do we write that? When when one vector is written as a linear combination of other vectors, so then they are linearly dependent. ये भी वैसी है. So one vector is a linear combination of other vector. But हम इसको simply ऐसा read करते हैं. We'll read this in a simple way that the one vector is a scalar multiple of other vector. So then these two vectors are linearly dependent, we say that. Okay, this is for 2 and this is for 3, like that. Okay, now is there any other way, sir? अगर मुझे जैसे वेक्टर्स को देख के ही मुझे समझ में नहीं आता है कि ये ऐसा है, तो देर इज अनदर वे सर. यस, देर इज एन अनदर वे फॉर टू वेक्टर्स. देखो बेटा, ये जो मैं कॉन्सेप्ट कर रहा हूं, ये दो वेक्टर के लिए, ये जो कर रहा हूं थ्री वेक्टर्स एंड थ्री डायमेंशन के लिए, राइट. सो इन दिस केस व्हाट आई डू इज रेशियो a1 by a2, b1 by b2, c1 by c2, right. What is, so I'll take this one as a1, b1, c1, a2, b2, c2, ऐसा है. So what is the ratio of this? That is 1 by 2. So 1 by 2, b1 by b2, 2 by 4, and c1 by c2, 1 by 2. Are they equal or not? See, are they equal or not? They are equal. If the ratios are equal, so that means it is very clear x1 and x2 are linearly dependent. जैसे ratios are equal, linearly dependent. If at least one ratio is not equal, so they are independent. They are independent. They are not dependent. Okay. Now this is another way of doing it. So there is another way is also there to understand this one, the dependency between two vectors. So this concept I am telling for only two vectors, my dear. Please understand this. Two vectors only. अगर जब आपके पास दो वेक्टर होता है, कैसे linearly dependency को देखना पड़ेगा, right. और दूसरी मेथड क्या, तीसरी मेथड. नाउ इट इज कंसिडर द 2 by 2 minors, because I can't have a 3 by 3 minor. Minor means determinant. याद रखना बेटा, minor means determinant. I can't have a 3 by 3 determinant here, but I can have a 2 by 2 determinant. That was the maximum minor I can have. So 2 by 2 determinant मगर एक नहीं होगा, 3-4 होगा, right. So yes, there are 3 2 by 2 minors you can write. So one is of, consider 2 by 2 minors. Yes, 1 2 1 2 2 4 2 4, and another one 1 1 2 2, right. Another one, it is 2 1 4 2 here. Okay, now this 4 minus 4 is 0, 2 minus 2 is 0, 4 minus 4 is 0 here. Now you can see all these 2 by 2 minors are zeros here. सारे 2 by 2 minors 0 है, तो जितने 2 by 2 minors possible हैं वो सारे 2 by 2 minors are 0. So that implies that x1 and x2 are linearly dependent. Okay, linearly dependent. Note, if you want to take note, if there exists at least one non-zero minor, non-zero 2 by 2 minor, then they are linearly independent. Then they are linearly independent. So please make a note of this under this problem. Under this problem. Okay? Right. Yes, multiple of integer. Yes, by observation it will be easy for us. Okay? All are one on see एक दूसरे से related है, they are not different here, but इतने different तरीके में हम देख सकते हैं लीनियर डिपेंडेंसी को. Yes, you can choose A1, A2 also. Yes, Sibash, you can choose A1, A2 also. But I told you, na, taking A1, A2, A3, it will take a lot of time. Instead of that, I am going for some other techniques and faster methods like this, which I told you there. Okay? Always we should be in the process of going for a shorter method and faster methods. Then only we can crack the answers very fast. Shweta Maurya, for 4 vectors, yes, for 4 vectors you need to take only one thing. One vector is written as a linear combination of other vectors. Okay. अच्छा, वो सिंबल समझ में नहीं आया क्या? I will read this to be. If there exist, I think CS students can understand that. That is a there exists symbol. If there exists at least one non-zero minor, 2 cross 2 minor, if there exists at least one non-zero 2 cross 2 minor, then they are linearly independent. Then they are linearly independent here. No confusion, nothing. That is for 3 vectors, this is for 2 vectors. 2 vectors के लिए ऐसा देखना है, अगर एक वेक्टर स्केलर मल्टीपल ऑफ अदर वेक्टर होता है तो डिपेंडेंट है, लीनियरली डिपेंडेंट है. अगर ऐसा नहीं पॉसिबल होता तो रेशियो देखना, रेशियो से अगर रेशियो सारे की सारे रेशियो सेम होता है, सो इफ द रेशियोस आर सेम देन दैट इज लीनियरली डिपेंडेंट है. इफ अगर रेशियो भी नहीं बना सकते हैं, so then we can go for 2 cross 2 minors. So if any 2 cross 2 minor is non-zero, then they are independent. But if all 2 cross 2 minors are zeros, that means they are linearly dependent. आगे आगे पता चलता है आपको where you have to use, right? Okay, beta. So I think no. So okay, I will mention here also, beta. This is for only two vectors. This is for only two vectors. ये जो रेशियो मेथड है only for two vectors. This is also only for two vectors. Please mention it, beta. This is for only two vectors. रेशियो मेथड इज ओनली फॉर टू वेक्टर्स, क्योंकि रेशियो में कितने वेक्टर्स का पार्टिसिपेशन हो रहा है? दो वेक्टर का पार्टिसिपेशन हो रहा है, मतलब आप दो वेक्टर के बारे में बात कर रहे हैं. सो देयर इज अ पार्टिसिपेशन ऑफ टू वेक्टर्स, दैट मीन्स यू आर टॉकिंग अबाउट द डिपेंडेंसी ऑफ टू वेक्टर्स ओनली, राइट? जस्ट हैव सम कॉमन सेंस इन दैट, राइट? So next here we are taking the minors from only those two vectors. So that means this is strictly used for only two vectors. Common sense, bas. So whichever you feel comfortable in the problems that you can do it. ठीक है. अब मैंने थोड़ा linearly independent के बारे में बताता हूं बेटा. Linearly independent के बारे में बताता हूं. चलो. Write down linear independency. Linear independency, linearly independent if the linear combination is getting 0 only for all ai is equal to 0. Please write down this definition of linearly dependency. बस इतना लिखना है बेटा. Yes. Yes, Annam Reddy, Venkat Vinay. Correct. If two vectors are ax plus by plus cz are parallel lines, means the ratios are equal. Very good, beta. Very good. That's correct, Mr. Venkat Vinay. सर 12th में लीनियर डिपेंडेंट एंड लीनियर इंडिपेंडेंट चेक करने के लिए ही मेथड सिखाते, बट there are many methods to check the it. Okay, thank you beta. Thank you Mr. Rajendra Prasad. Three vectors of 4 dimensions, how to find? Pandur Sai is asking that when 3 vectors of 4 dimensions are there, sir, then what to do? See, if it is of n vectors of n dimension, there is no doubt you have to go with determinant, minor or determinant, right? But if one vector is less, suppose, or two vectors are less, or three vectors are less when it compare with the dimension, so then what you have to do? Then you have to go for this when you have to go for the possible minors. I repeated very clearly that why I am considering 2 by 2 minors in this case. I repeat, I mentioned very clearly that when I have only 2 vectors of 3 dimension, I cannot have a 3 by 3 determinant here. I cannot have it. Since I cannot have a 3 by 3 minor, so I cannot decide the linear dependency with a 3 by 3 determinant. So then what I have to do here? In that, what is the minor I can get? What is the maximum minor I can get from these 2 vectors? That is of 2 cross 2 minor. That's why I have taken all 2 by 2 minus from those vectors. So similarly, the same case is applied in the case of 3 by 4. That means 3 vectors of 4 dimension, or 4 vectors of 5 dimension, or 5 vectors of 6 dimension, whatever it is. Done. Okay. Linear independency is linear combination is equal to 0 as you stated in the board. It is a non-zero. No. It is equal to 0. It is equal to 0. Yes, I'll explain this. Okay. I'll explain this. Okay. I'll just focus on this here. Yes, beta. This is what the linear independency here, right? What is that? Let me tell you. A set of vectors x1, x2, x3 and so on, xn are linearly independent if the linear combination, that is a1 x1 plus a2 x2 plus a3 x3 and so on, an xn is 0. Yes, it is equal to 0. But for non-zero coefficients, not for non-zero coefficients. It is 0 only for all ai is equal to 0. Matlab, it is very, very clear, my dear. This should be 0 only for 0 coefficients. Only for 0 coefficients. If this is getting 0, that means they are independent. Okay? Other than 0 coefficients, if you are getting some non-zero coefficients is also giving you 0, that means they are dependent. They are dependent. For non-zero coefficients it is getting 0, that means they are dependent. They are linearly dependent. Okay? But for only 0 coefficients you are getting it is equal to 0. For no other non-zero coefficients we are getting 0. So that means they are linearly independent. They are linearly independent here. Okay, बहुत सारा स्टूडेंट्स को बहुत सारा डाउट्स आता है, बट स्टिल आई एक्सप्लेन वेरी वेरी स्मूथली, वेरी वेरी क्लियरली हियर, बट स्टिल आई विल गो ऑन टू द फर्दर थिंग्स. बेटा यहीं से स्टक होना हमारा ये नहीं है, तो हम और क्वेश्चंस करते हैं. सो बाय डूइंग सम नंबर ऑफ क्वेश्चंस एंड एग्जांपल्स ऑल सच डाउट्स विल बी गेट क्लैरिफाइड. ओके, अब तो इतना समझना बेटा, दिस इज रिक्वायर्ड. नाउ यस, लेट्स गो विथ सम क्वेश्चन हियर which was asked in the recent examination, my dear. ये अब recent examination में एक question पूछा था. Let's take that question. Let's take that question, my dear. Question is that it is 2021 question. 2021 question, that is the vectors 1 comma minus 1 comma 2 7 3x 2 3 1, okay, in R cube are linearly dependent, then x is equal to dash. This is a 2021 question, my dear. Okay, this is right. So there are 3 vectors are given. R cube. R cube means what? Some people have this doubt with this R cube. R cube means it's a 3-dimensional real space of vectors. Real space of vectors. That means R cube is a set which consists of 3-dimensional real vectors. That's it. Simply, if you want to understand, it's a set of 3-dimensional real vectors. So this is a one real vector. This is one real vector. This is one real vector when x is a real number. So these are the three real vectors, and saying that these three vectors are linearly dependent. So then what is this x value? To find out this x, is there any hint is provided to us in this question? Yes. What is the hint is that? The hint is given that these vectors are linearly dependent here. Given that x1, x2, x3 are linearly dependent. Dear students, if three vectors of three dimension are linearly dependent, then the determinant must be is equal to 0 here. So linearly dependent, this implies that the determinant of x1, x2 and x3 should be is equal to 0. This is of 3 cross 3. So now here I can write that this one has 1 minus 1 2, x2 is 7 3x, and then 2 3 1, and this is equal to 0 here, right? Okay, so then this will be of x is equal to, you are going to get, actually let me expand this, or you can expand. This is plus minus plus. So 1 into 3 minus 3x minus 7 into, that is minus 1 minus 6, that is minus 7, plus 2 into, this one is minus x minus 6 is equal to 0. Minus x minus 6 is equal to 0. And from this, the x value you are going to get, that is 8 here. 8 is the answer for this. No beta, 26 is wrong answer, 5 is wrong answer, 8 is correct answer, 6 is wrong answer, 3 is wrong answer, 4 is wrong answer, Santika, I think you are clear, right? It is equal to 0 only, it is not non-zero. Actually I changed the definition, na? So that you did not go through it. Yes, Anirba. 8 is the right answer. 8 is the right answer here it is. Hope you understand. Now, you take the property dear, all of you. All of you take the property here. Let's take a property. Let's take a property. All of you, let's take a property. If any two rows or columns, if any rows or columns, not only two, you can write like this. If any rows or columns are linearly dependent, if any rows or columns are linearly dependent, then the determinant of that matrix is 0. Yes, Harini, you can take the vectors in rows also. Yes, Harini, you can take the vectors in rows. No, Chaitanya, don't go with that. No, Chaitanya, it is not advised. It is not advised. Please don't go with that. When you have a 3 vectors of 3 dimension, it is to be the maximum minor is going to be 3 cross 3, but not 2 cross 2. Mr. Chaitanya Srinivas, please understand. Okay, so let's row wise. Yes, you can go for it row wise also. No issue. You'll get the same answer. Right. So I think you have taken. So property, I think you have written na? Property that if any rows or columns, that means the vectors. Okay. If any rows or columns are linearly dependent, then the determinant of that matrix is 0. Then the determinant of the matrix is 0. Acha, somebody, Renuka is asking that can the sequence of x1, x2, x3 be changed and get the same results? Yes, why not? Okay, you will get the same answer because the other side it is equal to 0. No, Mr. Varun. You have to write as it is. If any two rows or columns, if any rows or columns are linearly dependent in a matrix, then the determinant of the matrix is 0. Okay. I think I should go ahead fast. Right. So, right. Okay, beta. So now if I say that Ri is equal to k times of Rj, so then this Ri and Rj are linearly dependent. Second one is that Ri is equal to lambda 1 Rj plus lambda 2 Rk. So then Ri, Rj, Rk are linearly dependent. So this is for similarly for columns. Similarly for columns here. So please make a note of this. This is the linear dependency. अगर linear dependency को देखते हैं तो this is the way. If one row is proportional to other row, so then they are linearly dependent. If one row is the linear combination of other rows, then they are linearly dependent. So the same dependency we can apply even on columns also, right? So vectors का मतलब ये होता है कि they may be row vectors or they may be column vectors. When I say vectors, you understand that yes, they can be rows or they can be columns here. So that's what the same thing I have written, the linear dependency for rows and columns in a matrix here. Rows and columns in a matrix. So please make a note of this point, all of you. Please take it fast. I think we are wasting some time here. Right? Okay. Now, the next point. Yes. Now, take a note here. Take a note. The definition of linear dependency. Write down this note. The definition of linear dependency and linear independency. The definition of linear dependency and linear independency remains same for the set of vectors, comma rows, comma columns, and functions, etc. Functions, etc. Right. Definition of linear dependency and linear independency remains same for the set of vectors, rows, columns, and functions, etc. Okay. So the same definition in place of vector, so you can take the functions. In place of vectors, you can take the rows. In place of vectors, you can take the columns. In place of vectors, you can take any polynomials or any functions, anything here. But the definition of linear dependency and independency is same. That means if one function is written as a linear combination of other functions, okay, if one polynomial is written as a linear combination of other polynomials, if one function is if one row is written as a linear combination of other rows, if one column is written as a linear combination of other columns, they are linearly dependent, else they are linearly independent. Hence they are else they are linearly independent. So this is one definition I just wanted to give you here. Now my dear students, I am going to give you an example here. I have some set of vectors here. So you just tell me this is cos square x and sin square x here, and then cos 2x. Cos 2x. Now is LD or LI? So what is the answer for this question? So what is this answer for this question here? So we have a function f1 and f2 and f3. So we are having three functions here. Now these three set of these three functions is linearly dependent or linearly independent. Okay, like that. Panduri Sai, I think he's showing all the talent, but don't go in that way. Stick to my knowledge, so that you will not have any confusion. But if you think of your pre-existing knowledge, I'm telling you, you will not understand the linear dependency concept. You will be out of the concept. I'm telling you very very clearly. मैंने इसलिए प्रिकॉशन पहले ही देता हूँ. जब लीनियर डिपेंडेंसी पढ़ाता हूँ ना, ढेर से अच्छी तरह समझना है. Otherwise you will have some problems in understanding or anything. Just go with my knowledge. Just whatever the way I am explaining here, you just go with it. Right. So set of this function. मैंने क्या बताया बेटा? The definition of linear dependency and independency remains same even for functions also. Functions also it is same. So now according to this LD and LI, my question is this, that is this any one function can be written as a linear combination of other functions or not? Can you write one function as a linear combination of other functions? That's my question here. Dear students, as these are trigonometric functions, so we know that we have some trigonometric identities for cos 2x. For cos 2x. So what is the cos 2x trigonometric identity in terms of cos square x and sin square x? Yes, that is cos 2x can be written as cos square x. I can say like this. So here cos square x minus sin square x here. So this is nothing but here f3 is equal to so 1 into f1 minus plus minus 1 into sin square x, that means f2 here. Now you can see this, my dear students, very very clearly. f3 is written as the linear combination of f1 and f2 here. So therefore I can say very clearly that f3, f1 and f2 are linearly dependent. They are linearly dependent. Yes, f3 is equal to f1 minus f2 is giving you. So one function is given by the linear combination of other functions. So therefore set of these three functions are linearly dependent. Okay, linearly dependent. Very good. Somebody said Bhavana, सही है, but Monica is wrong answer. They are linearly dependent. Linearly dependent. Okay. So now I will go with another set of these things. Second example. So these things, e power x, e power minus x and x. So in this one, so here F1, this is F2, this is F3 here, right? So now we can say very, very clearly here. So A1 F1 plus A2 F2 plus A3 F3, okay, is equal to 0 only for AI is equal to 0. That means A1 into e power x plus A2 into e power minus x and then plus A3 into x is equal to 0 only for A1, A2, A3 is equal to 0. Hence they are linearly independent. They are linearly independent. So this cannot be 0. ये कभी भी 0 नहीं देगा. Okay, you won't get 0 at all. E power x expansion मालूम है आपको? Do you know the e power x? See, this e power x and this e power x will be same only for x equal to 0, but not for 1, 2, 3 and 4 na. So therefore general e power x and general e power minus x, this linear combination never be 0 here. So therefore, so they cannot have any linear dependency. Thank you. Yes, they are all linearly independent. Correct. They are all linearly independent here. Right. So this is one thing here. Now, I just wanted to take another example here, that is sin x, cos x and tan x is Li or Ld? That is my question. Tell me, what is the answer for this? Li or Ld? Is Li or Ld? That is my question, my dear. ये Li है Ld है, जल्दी फटाफट करना है. So देखो, you cannot write, this is suppose here this is F1, this is F2, this is F3 suppose. So if I take F3 is equal to, that is tan x is equal to, okay, F3 is equal to, so A1 sin x, okay, plus some A2 cos x, okay, if I write like this. So that is A1 F1 and then A2 F2. Now this is going to be tan x is equal to A1 into sin x plus A2 into cos x. Now I am asking you, my dear students, is there any A1 A2? Is there any A1 A2 so that non-zero A1 A2 so that A1 sin x plus A2 cos x will give you tan x? Is there any chance? Is there any chance? No chance. Why? Because I'll tell you. At pi by 2 this is infinite, but at pi by 2 this is finite. और ये भी finite है, right or not? So sin x is a finite function, cos x is a finite function, but tan x is an infinite function. So the linear combination of finite functions cannot give you the infinite function here. So therefore this is impossible. This is impossible, right? All of you understood? So this is impossible. So therefore they cannot be linearly dependent. They are linearly independent only. So now I can write here. So this cannot be here. Infinite is equal to, so this one. So it is not possible. It is not possible for any A1 comma A2. For any A1 comma A2 belongs to R. So therefore they are linearly independent. They are linearly independent. Okay, they are linearly independent. Somebody is saying, yes sir, linear combination can't happen, but I took, okay, fine Bhavna, that is not a linear combination, correct. Yes, you can't take Gaurav. So F3 is equal to F1 by, somebody is saying that F3 is equal to F1 by F2. But this is not a linear combination. ये लीनियर कॉम्बिनेशन ही नहीं है, ठीक है, ये लीनियर कॉम्बिनेशन नहीं है बेटा. सो देयरफॉर ये रिलेशन जो है उसको लीनियर डिपेंडेंसी में आता ही नहीं है, ठीक है. और लीनियर डिपेंडेंसी और इंडिपेंडेंसी कॉन्सेप्ट में ये रिलेशन नहीं लेते हम लोग. वी डोंट टेक दिस रिलेशन इनटू लीनियर डिपेंडेंसी एंड इंडिपेंडेंसी. ओके, राइट. एनीवे, so this all questions I have shown you here in the case of linear dependency. चलो हम इसके ऊपर से क्वेश्चंस करते हैं बेटा. सो हमारा कहना ये है कि एक्चुअली आई वांटेड टू शो यू देयर इज वन इंपॉर्टेंट पॉइंट हियर. चलो हम प्रॉब्लम्स के बिफोर गोइंग इनटू द प्रॉब्लम्स लेट मी क्लियर दिस वन हियर. इफ वन रो इज रिटन एज अ स्केलर मल्टीपल ऑफ अदर रो, or if one row is written as a linear combination of other rows, that means they are linearly dependent. Okay, right. आपको already मालूम है कि property already you have written that here, if any linear dependency exists in a matrix, so then the determinant will be 0, right? This point also you have written into your notes. So now I am going to take some questions and now you have to give the determinant for those answers here. Chalo, let me take that question. Now we take this example here that the determinant of here 1 2 3 2 minus 1 1, so this is 3 1 4 here. So what is the determinant of this matrix? What is the determinant of this matrix here? Shruti, look at the graphs of sin x and cos x and tan x. You will understand. At x equal to pi by 2, sin x is finite. Cos pi by 2 is 0. Sin pi by 2 is 1. Tan pi by 2 is infinite. It's very simple. चलो बेटा, ये डिटर्मिनेंट क्या होता है. बट माय डियर स्टूडेंट्स, आई एम नॉट इंटरेस्टेड इन एक्सपैंडिंग दिस. प्लीज ऑल ऑफ यू अभी सुनना बेटा, बहुत इंपॉर्टेंट है, बहुत इंपॉर्टेंट है, देखना पड़ेगा. ये हम प्रैक्टिस कर रहे हैं बेटा, लीनियर डिपेंडेंसी को हम प्रैक्टिस करना पड़ेगा. सो इफ यू प्रैक्टिस द लीनियर डिपेंडेंसी, okay, so that it will be used as a shortcut in many of the problems, so that you will enjoy, right? So first, before going into that, first let us use the linear dependency concept on this. There are three rows, R1, R2, R3 here, right? There is a C1, C2, C3 here. Now there are three columns and three rows here. Now my question is that, is there any linear dependency? If there is any linear dependency, the determinant will be 0. Correct or not? Yes. So is there any linear dependency among the columns or among the rows? Kuch bhi, anyone you take it. See here, 1 plus 2 is how much? 3. 2 minus 1 is how much? 1. 3 plus 1 is how much? 4. So it is very clearly observation. By observation here, it is very, very clear, my dear students, that is C3 is given by C1 plus C2. Do you accept it? Right. C3 is equal to C1 plus C2. So one column is written as a linear combination of other columns. That means this C1, C2, C3 are linearly dependent. So therefore, this determinant of A3 by 3 is equal to 0. The determinant of A3 by 3 is equal to 0 here. So hope you have understood this question. Now let me take another question here. The determinant of 2 1 2 1 minus 1 minus 1 1 1 1 0 2 3 and 0 minus 1 3 4. So this is 4 cross 4 determinant. So what is this determinant here? My dear students, before going in expansion of this determinant of 4 by 4, first of all, I want to make you do some practice of linear dependency among the rows and columns. So, is there any linear dependency among the rows or among the columns or something like that? Anyone, you take columns or you take rows, whichever you feel comfortable in identifying the dependency as fast as. जिस पे आपको जल्दी से जल्दी लीनियर डिपेंडेंसी मिलता है तो आप उस पे जा सकते हैं, राइट? देखो बेटा, इसमें क्या होता है, right? Tell me what is going to be happen in this, right? First you take the row 1, row 2, row 3 and row 4 here. There are 4 rows are there. Is there any linear dependency here? Let us check it. 2 minus 1 is 1, 1 minus 1 0, 2 plus 1. Oh, this is something wrong here. Just a minute. This is, just a minute बेटा, ये कुछ गलत हो गया ना. 2 1, अच्छा यहाँ पर कुछ, just a minute. 3 2, just a minute. I'm sorry. Yes. So this is the 4 by 4 matrix. I'm sorry. This is the matrix here. This is the determinant here. Now, is there any linear dependency now? Very good, very good. Many of the students have given 0 is the answer. But Sharan, आप तो गलत दिए बेटा. ध्रुव चाटर, वो भी गलत दिया है. अभय, ध्रुव, यू आर रॉन्ग. अनिकेत राठौर, आप भी गलत दिए बेटा. पंडुर साई गलत है. यू आर रॉन्ग पंडुर साई. Being dependent, very good. Yes, correct. Yes, very good. Oh, Sibash, wrong answer beta. Very good. Thank you, Abhay. Oh, very good. Excellent. Many of the people have responded and they were giving the answers. Wonderful, beta. Wonderful. So this is what, the way you have to practice so that you can understand, you can learn the things you can learn many things in a very less time. चलो बेटा. So यहाँ पर by observation देखते हैं बेटा. By observation थोड़ा ध्यान से देखते हैं. Right. R3 is given by R1 plus R2 or not. 2 minus 1, 1, 1 minus 1, 0, 2 plus 1, 3, 1 plus 1, 2, right? So R3 is equal to R1 plus R2. So if at least one dependency, अगर एक भी dependency है, so answer क्या है? 0. So these three are linearly dependent है, तो determinant 0 है. सीधा determinant 0 बस. It is enough to say one dependency. It is enough to say the determinant 0 for one dependency. बट नाउ ओके, थोड़ा प्रैक्टिस करते हैं. इसके अलावा R1, R2, R3 के अलावा और कोई लीनियर डिपेंडेंसी है क्या? इज देयर एनी अदर लीनियर डिपेंडेंसी अमंग द रोज? कम ऑन, एनी अदर रोज, एनी अदर लीनियर डिपेंडेंसी, एनी अदर लीनियर डिपेंडेंसी बेटा? -1 + 1 0, -1 + 0 -1, 1 + 3 4, 1 + 2 3. So it is very clear that R4 is given by R2 plus R3. So therefore, here one vector is given as a linear combination of other vectors. So therefore, here R1, R2, R3 are linearly dependent here. So linearly dependent है, तो ये भी एक linear dependency है, ये भी एक linear dependency है, right? तो आपको एक थोड़ा सा homework देना चाहता हूं. So please identify the column dependency. Identify. What is the homework for you is here? Identify the column dependency in this problem. In this question, identify the column dependency. ठीक है, right? But to say the determinant 0, one dependency is enough. Just one dependency is enough, beta. You need not to go with all dependencies here. One dependency is enough. So that one dependency you got it, and you got the answer 0. Wonderful. Yes. Now elementary transformation, beta. Now elementary transformations here. Now elementary transformations. So what are elementary transformations? Are basically there are row transformations and they are column transformations here. There are column transformations and there are row transformations here. Okay. Now no column dependency, sir. Hari Om, it is there. C1 minus C2 is equal to C3 minus C4. It is there. वेरी गुड. मतलब आप देखो बेटा, ये कंपल्सरी नहीं है कि आप कैसे भी ढूंढना ही है, ठीक है. सो समटाइम्स रो डिपेंडेंसी इजी बट कॉलम डिपेंडेंसी इज डिफिकल्ट. समटाइम्स कॉलम डिपेंडेंसी विल बी इजी देन द रो डिपेंडेंसी. सो कौन सा इजी लगता है उससे जाना पड़ेगा, ठीक है, राइट. एलिमेंटरी ट्रांसफॉर्मेशंस आर आइदर रो ट्रांसफॉर्मेशंस और कॉलम ट्रांसफॉर्मेशंस हियर. So by applying these elementary transformations here, the matrix will be changed to other matrix. By applying the row transformations and column transformation, matrix will be reduced to another matrix here. Another matrix here, right or not? Definitely the matrix will change. Okay, sir. The matrix changes, then what about its determinant changes? So what about its determinant? Whether the determinant of the matrix will get changed or not. So do you want to know? So exactly whether by applying the elementary transformations, okay, that is row transformations or column transformations, whether the if the matrix, definitely the matrix changes, but if the matrix changes, then the determinant will change or not. So do you want to know? Just look at these rules, all of you. So I will tell you how what kind of change will takes place in the determinant for each elementary transformations. They are given by rules. So rules of elementary transformations. Rules of elementary transformation. So that is rule 1 beta. What is rule 1? So rule 1 is that here, if you are interchanging any two rows, if you are interchanging any two rows in the given determinant of the matrix, so then the determinant will change by minus. So that means the determinant of A is equal to determinant of B is equal to minus of determinant of A. Minus of determinant of A here. So when you are interchanging, see, interchanging of two rows or two columns is nothing but one elementary transformation. So this is an elementary transformation there. ये एक elementary transformation है जिसके वजह से इतना determinant, this is the change in the determinant, you can understand. Okay, right. Then next, that rule 2. So in this, if any row is multiplied by a scalar, if any row is multiplied by a scalar, so this is also another elementary transformation here. This is also another elementary transformation. So by multiplying any non-zero scalar or any scalar to any row, so then what kind of change will takes place in the determinant? Then the determinant, that is the mod of that means the determinant of the resultant matrix is equal to k times of the determinant of original matrix. So this property we have discussed in property 5 of determinants. Next one, the rule 3. Yes, I am going to take on another elementary transformation, that is Ri to Ri plus lambda Rj. So this is an another elementary transformation dear. ये दूसरा elementary transformation, sorry तीसरा है, right? So then what? There is no change in the determinant. Then the determinant of the resultant matrix will be equal to the determinant of the original matrix here if you apply this. So when you apply this rule, or when you apply this elementary transformation, the determinant change by minus, and if you apply this transformation, so the determinant is getting k times of its original determinant, and when you apply this rule 3, so then there is no change in the determinant. Then there is no change in the determinant here. Okay, I hope you understand this. So when you apply this, minus will occur. When you apply this, the determinant will get changed by k times, and when you apply this kind of elementary transformation, there will not be any change in the determinant here. So these are the rules, rule 1, rule 2, rule 3. So which will make you to know that how, how that elementary, which elementary transformations will change the determinant value, and if at all it changes, how much change will take place due to each elementary transformation. So this is what I have clearly explained here. I hope it is clear for everyone, right? So please copy this, all of you. In another 5 minutes our class is going to finish. Now let's take one question here, right? So A is equal to 3, 4, 45, 7, 8, 105, 13, 9, 13, 2, 195 here. This is the matrix is given to us, right? By applying the following, the transformations, that is first one is R2 to R2 minus R1, and second one C3 to C3 minus 2C1, C3 minus 2C1. Right. By applying this following transformation, the determinant of the resultant matrix here is dash, right here. By applying the following transformation, so these are the transformations you apply here. So then the determinant of the resultant matrix is what? So what is the determinant of resultant matrix is? This is the question, my dear students. Now let me finish this question by applying the concept which I told you above. Right. All of you, please understand this. See, he is ultimately what he is asking that. Please understand this here. Terminology. ये terminology समझना बेटा. Determinant of the resultant matrix. That means the changed matrix. So determinant of the changed matrix. So for how it is changes? By applying these transformations. So these are the elementary transformations which applied here on the given determinant. On the given determinant. Okay. Now because of these transformations, the determinant will be getting changed. But if at all it changes, how much it changes? Right? So we already discussed that for each transformation, how much change will take place in the determinant, I already discussed. Now you look at this, all of you, that yes, is it what type of rule here? Is it what type of rule here? This one is on which rule here? R2 to R2 minus R1 is which rule? And C3 to C3 minus 2 to C1 is which rule here? ये कौन सी rule है? Is it R1 rule 1? No. Is it rule 2? No. It is rule 3? Yes. It is also rule 3? Yes. So since I can say both operations are, acha, because of rule 3, since this is rule 3, this is rule 3, okay, both are of rule 3, so then will there be any change in the determinant of this resultant matrix? No, there won't be any change in the determinant of the matrix here. So therefore, to find the determinant of the resultant matrix, it is given by the determinant of A. So I will just write in this way, my dear. Since both transformations are of rule 3, okay, so therefore, so because of the rule 3, there won't be any change in the determinant. There won't be any change in the determinant. So therefore I can simply write like this. So therefore by rule 3, so determinant of B is equal to determinant of A, right? So that is the determinant of here 3, 4, 45, 7, 8, 105, and here 13 and 2, 195 here. 195. So I have to find the determinant of this 3 by 3 matrix. But you just check it once here. If you want to find out this determinant, because of this last column having big numbers, so it takes very lot of time to evaluate the determinant of 3 by 3. So then what I do is I will take some techniques in that. What is that is, see this in last column, that wherever the big numbers are there, are they multiple of any number? Are they multiple of any number? Yes, this is a multiple of 15, this is a multiple of 15, and this is also multiple of 15. So therefore I will write like this, my dear. ये मैं ऐसा लिखता हूं, देख लीजिए. Since here C3 is here, okay, not this way. Now what I do is, okay, I'll take 15 common in this. So 15 is taken common from the last column, so that you get 3, 4, 3, 14, 15 3s are 45, 7, 8, 15 7s are 105, and 13 2, and 15 13s are 195 here. So this is we are getting as 13 here. Now you tell me, my dear students, here the C1 and C3 are equal or not here. So since C1 is equal to C3, so this determinant is equal to 0. Since C1 is equal to C3, so these are linearly dependent. So therefore the determinant is 0. Therefore the determinant is 0 here. So this is the answer for this question, my dear. So by applying this elementary transformation, what will be the change takes place in the determinant, that we can easily identify with the help of these rules. If you know these rules, so you can get the answer for this kind of questions very quickly and very fastly here. So that's why these rules are important here. And this was one of the gate examination question. यह एक गेट एग्जामिनेशन क्वेश्चन है, बहुत इंपॉर्टेंट है, ठीक है. चलो, okay. So with this I'm concluding the class for today. So tomorrow I'll be taking the some more finding the determinant of the higher order matrices, some shortcuts, and then we'll go to tomorrow inverse of matrix, and then rank of matrix also we'll do it tomorrow. So tomorrow is a very very important class for all the basics to get connected. Okay, right. I hope you enjoyed this class beta. Linear dependency concept अब सब लोगों को अगर किसी के if anyone has some issue or कहीं कुछ gap दिखता है, so if you feel that anyway somewhere is not clear or something like that, please look at the notes once again and try to listen to this note class once again, and so that you will be getting clarified. And अगर मैं एक ही point बताता हूं बेटा, if any concept you want to get perfect means वो concept पे आप बहुत अच्छा practice करना है. So if you do a good practice on that particular concept, so definitely you will be confident and any confusion confusion free you will be. Okay, everything will get clarified. So right beta, thank you and bye bye. Same timings. So tomorrow timing is same, that is 2 to 5 p.m. Okay, so tomorrow timing is 2 to 5 p.m. Two to 5. Thank you, thank you, thank you, thank you. Very good, very good. I'm so happy to listen from all of you that yes, thank you, thank you. Very good, beta, very good. I'm so happy for you all. Chalo.